Hi, I'm Keerthana, and my mentor was Alejandro Falsatore, who's a professor at Hunter College in New York. So, this research study delves into the intricate intersection of racial and economic disparities within the framework of facial recognition technology as integrated into the public surveillance system of New York City. By investigating the impacts of this innovation, the study illuminates how these disparities manifest and potentially perpetuate within the urban context. Additionally, the study probes the underlying factors that contribute to these disparities, as data bias, algorithmic shortcomings, and socioeconomic inequities. So this is my table of contents, and each slide will correspond to one section of my paper. So this section aligns with my literature review. Foundational studies like Regano 2018 helped me center my topic where further research needed to be conducted. Now let me introduce you to some keywords for my project. So public surveillance refers to the systemic monitoring of public spaces using various technologies and methods to observe and record activities and behaviors of individuals within those areas. Closed circuit television, or commonly known as CCTV, is a surveillance system that uses video cameras to monitor and record activities in specific areas. It's widely used in public spaces for security purposes, and this system helps deter criminal activity and provides evidence for investigations while enhancing public safety. Moving on, facial recognition technology is a biometric system that analyzes and identifies individuals based on their facial features. It's gained significant attention and adoption in various fields due to its potential applications, as well as concerns related to privacy and ethics. This technology involves data collection, pre-processing, and feature extraction, followed by training machine learning algorithms. In particular, the one that I followed was convolutional neural networks, or CNNs. These algorithms learn to map facial features to specific identities, enabling real-time recognition and identification of faces. Moving on, racial biases and economic disparities are highly perpetuated in New York City society. The city's economic disparities are stark, with concentrated pockets of poverty often intersecting with neighborhoods where racial and ethnic minorities predominantly reside. The spatial overlap between poverty and minority communities can lead to heightened levels of police presence and scrutiny, which contribute to a vicious cycle where residents in these areas are disproportionately targeted for minor offenses. So this leads me to my research question. How does racial and income distribution in New York City influence the effectiveness and accuracy of facial recognition technology used in CCTV public surveillance footage for crime prevention and investigation? To answer this question, I looked at four main data sources for the research study examining disparities within New York City's facial recognition technology integrated into public surveillance. Data from IPUMS, or Integrated Public Use Microdata Series, and NHGIS, National Historical Geographic Information Systems, were invaluable sources of information. So the IPUMS provides access to data from the US Census and other national surveys, which help researchers to extract demographic and socioeconomic information at a very small level. And NHGIS, on the other hand, contributes to the research by offering geospatial data that can be integrated with demographic and economic indicators. And this allowed me to contextualize disparities within the framework of urban geography and the neighborhood characteristics in New York City. And lastly, I used NYC Dot, which had real-time traffic cameras, which I used to map out with the CCTV locations. So the methodology employed for this research study involved a comprehensive analysis conducted through RStudio, which is a powerful integrated development environment for the R programming language. The initial phase of the analysis comprises data collection and pre-processing. Relevant data from sources such as IPUMS and the NHGIS are extracted using RStudio's data manipulation libraries. Subsequently, statistical analysis are conducted to explore the relationships between racial and economic disparities and the deployment of facial recognition technology within New York City. Descriptive statistics, inferential analysis, and spatial visualization are employed to uncover patterns, correlations, and potential causative factors. Lastly, RStudio's extensive range of packages and visualization tools facilitate these analysis and allow researchers like myself to generate meaningful insights from complex data sets. Next, we're going to move on to results and findings. The findings of this research not only shed light on the technical aspects of facial recognition technology, but also unveil the broader societal implications it poses, including issues of privacy, civil rights, and social justice. Ultimately, the study contributes to a nuanced understanding of the challenges associated with the integration of facial recognition technology within urban surveillance systems and provide insights at addressing these disparities. Through RStudio's program, the CCTV camera locations were then tested and compared against a proportion of other elements. To do so, a goodness of fit test was implemented to test for truth behind the initial hypothesis. Four significant regions of New York City were selected for increased analysis based on population density and areas of commercial activity. With the help of RStudio's programming-based mapping system, there were numerous diagrams and visuals to assess the understanding of these variables of the criminal justice related activities happening in New York City. These were two of the visuals that I created that helped me base my findings. The research findings indicated that neighborhoods with higher concentrations of racial minorities and lower socioeconomic status tend to have a higher density of surveillance systems compared to more affluent and predominantly white neighborhoods. First, the historical patterns of redlining and discriminatory housing policies have led to the clustering of racial minorities and low-income individuals in specific neighborhoods. Second, the use of surveillance system technology often intersects with the concepts of broken windows policing, which disproportionately targets minor offenses and quality of life violations. Such policing strategies tend to concentrate in neighborhoods with higher poverty rates and larger populations of racial minorities, which leads to an overrepresentation of surveillance system cameras in these areas. Moreover, wealthier neighborhoods may have greater resources to invest in private security systems, reducing the perceived need for public surveillance system infrastructure. In contrast, financially strained communities may lack the means to establish such systems, leading to higher reliance on publicly funded surveillance. Several potential limitations may also impact the scope and finding of this research project. First, the accuracy and comprehensiveness of the data from sources such as IPUMS and the NJGIS could influence the reliability of the analysis. If the data contains errors, omissions, or biases, it could lead to inaccurate conclusions. Second, the ethical considerations on the use of facial recognition technology raises concerns. The lack of transparency from government agencies or technology providers in disclosing the full scope and methods of technology deployment might hinder a complete understanding of its impact. Despite these limitations, a thoughtful consideration of these factors will provide valuable insights into the complex interplay between technology, social disparities, and urban surveillance. Next, we'll move on to conclusions. So in conclusion, this paper's objective seeks to understand how racial and income distribution in New York City influences the effectiveness and accuracy of facial recognition technology used in CCTV-based surveillance system. This is then used for crime prevention and investigation. So hence it was found that there's a significant relationship between these variables, which poses a question to its reliability and fairness of the prosecutors of New York City. So in the future, for further investigation, I would recommend other researchers not only replicate methods, but also include a larger focus on the integration of public surveillance footage in criminal proceedings. And for the Talaria Summer Institute experience, so for researching strategies in high school, I took AP research and I was able to really advance my skills in qualitative data analysis, but through working with my mentor, I was able to learn how to use RStudio, which really enhanced my quantitative analysis and statistical skills. So I want to thank my mentor for showing me how to do all of this and able to analyze my data sets. I'm definitely going to use RStudio in future research endeavors and definitely pursue this topic to find more about how criminal justice and the upcoming use of AI is being integrated. And these are my references.